Welcome back. The topic is elimination of left recursion. We know what is meant by left recursion, whether it is direct left recursion or indirect left recursion. Now we need to eliminate left recursion. First of all, let me tell you why we need to eliminate the left recursion is. The reason is compiler generally designed by two ways. One is top-down approach or bottom-up approach. This is the two approaches to design a compiler. One is top-down approach, bottom-up approach. Okay, if you are choosing for the top-down approach, okay, how the compiler is going to generate the parse tree is, first it is going to generate the root node, then its interior child nodes, then its child nodes, then its child nodes, and its leaf nodes. Okay, and its leaf nodes. This is how parse tree is generated by using the top-down parser. Okay, as we have seen in last lecture, okay, how the parse tree is generated. If it is the left recursive grammar, is parse tree is generated in one way only. Okay, that's why we need to eliminate the left recursion. Okay, let me tell you how to eliminate the left recursion. Take the direct left recursion. So direct left recursion is the A tends to A alpha slash beta. A tends to A alpha slash beta. Okay, see, to remove the direct left recursion, we need to introduce some more one more non-terminal so that we can write the grammar without left recursion. Okay, let me introduce a new non-terminal as the a dash. Okay, how we can write the same grammar without the left recursion is I can write like a tends to beta a dash, So I'm introduced. What is the new non-terminal I'm introduced? A dash. Okay. Now a dash tends to alpha a dash. Then we need to add slash beta, then slash alpha. Okay. This is one approach. Okay. Even you can write with epsilon also. I'm directly removing epsilon instead of a lengthy procedure. Let me write like this. Okay. So if it is the left recursive grammar and this is a grammar without left recursion, how we are written? Okay, introducing what is new non-terminal? A dash. Okay, let's check this method by taking one example grammar. Yeah, let's take the example. So first check whether the left recursion exists or not. How we can write this is, so take this one. So this is E tends to E plus T. Okay, apply this method. Apply this one. So this is what? This is the A and this is the A and this is the alpha. Then if you write T, what is this one? It is the beta. So how we can write? This is the formula, right? So how we can write? Now what is A? So this is equivalence to how we can write is this is A, E tends to beta. What is beta? So what is beta part? It is T. Then next we introduce new non-terminal is A dash. For maintaining similar naming conventions, you take the new non-terminal name is the E dash. Okay, then slash beta. What is beta part? T. Then next, what is A? Next one is A dash. Here it is what? E dash. So now E dash tends to alpha. What is alpha part? Plus T. Then A dash. So A dash is what? E dash. Then slash alpha. What is alpha? Plus T. Okay, this is how we can convert this production which have the left recursion into the non-left recursive grammar. Okay, then we have one more production, right? So what is that production? So this is second one. So now take the second one. Yeah, so tell me what is that? T tends to T star F slash F. Okay, so as for this representation, what is this? So this is the A and this is the A and it is the alpha and it is the beta. Okay, so how we can convert? So apply this formula. Now how we can write? So it is T tends to what is this? Beta. What is beta part? F. Then what is now we need to write a dash. So maintaining naming conventions, so we are introducing new non-terminal name is t dash. Okay, then t dash slash what is beta part. So a tends to beta, then this is beta part, then a dash is this one, then beta is what? Beta is what again? F. Then next, then t dash tends to what is this? T dash tends to alpha a dash slash alpha. So what is alpha part? It is star f. Alpha part is star f. Then alpha a dash, I mean it is t dash slash alpha. What is alpha? Star f. Okay, so this is the left recursive production, and its equivalent production without left recursion. Okay, so now let me write down entire grammar at once. So this is so now write down entire grammar. So it is the left recursive grammar. Equivalent grammar without left recursion is the all this production. What is the production? E tends to t e dash slash t. Then next e dash tends to plus t e dash slash plus t then next t productions. T tends to f t dash slash f, then t dash tends to star f, t dash tends to star f t dash slash star f, then at last f tends to id. So it is the equivalent grammar without left recursion. Okay, see, one important thing is here is you can cross check whether your answer is right or not also. Okay, see, if you consider this one, as you know, in last lecture we understand this grammar generates the one string. What is that string? id plus id star id. Okay, this grammar generates, which grammar it is? A grammar which has the left recursion. Okay, same string should be generated by this grammar also. Which grammar it is? The grammar without left recursion. We can also cross check this one. Okay, see, write down. So how we can generate? You have to take starting production. E tends to t e dash. Okay, E tends to t e dash. Now t can replace with what? F. Okay, t can replace with f, it is e dash. Now then f can replace with id e dash. Okay, so e dash is derived. Then what we are expecting from this next one is plus id star id. So now e dash can be written as id plus t. Okay, now e dash can be written as plus t. So what is derived? Plus is derived. Then t can be written as what we are expecting, id star id. Now t can be written as id plus, now what t can be written as? Either f t dash or f also. Okay, so we are expecting star, I mean id star id. So that's why how we can write it is, now t can be replaced with f t dash. Okay, so now f can be replaced with id plus f can be replaced with id. So then t dash, so id plus id is also derived. Then t dash can be replaced with two ways, star f t dash slash star f. Okay, but we are expecting is what? Star d only. So it should replace with like id plus id star f only. So star f. Okay, then f can be replaced with id. Now it is id plus id star id. See this. So here also id plus id star id derived from the grammar with left recursion. Okay, so this is the grammar without the left recursion. Same string is derived. Okay, you can cross check this one like this. You can cross check whether your answer is right or wrong. Okay, now take another example. Actually the previous example is the direct left recursion. We know how to remove direct left recursion. It is a tends to a alpha slash beta can be converted into a tends to beta a dash slash beta, a dash tends to alpha a dash slash alpha. Okay, now take this is the another example for the indirect left recursion, not the direct left recursion, because you know this S tends to A slash B, then A tends to SC slash D. Okay, if in the place of if you replace SC, now SC is repeated, so it is the indirect left recursion. Actually, see, the direct left recursion removal and indirect left recursion removal both are proposed by one famous mathematician and research scientist. His name is Moore's algorithm. He suggested some algorithm. Okay, according to him, we can convert this indirect left recursion. We can remove the indirect left recursion from the grammar. Okay, see what his proposal is. First, you rename all. You identify what are the variables in this grammar. What are the variables in the grammar? S and capital A. Okay, what are the terminals in the grammar? Small a, small b, small c, small d. Yes, let me write down instead of all this. So V equals to capital S, capital A. Then T equals to small a, small b, small c, small d. Okay, see now you rename these variables. Okay, so now S can be named as A1 and A can be named as A2. Okay, now rewrite these productions. Okay, now how we can write it as? Now it is A1 tends to A2 A slash B, then next A2 tends to what is this? A1 C slash D. Okay, right? So according to the Moore's algorithm, you arrange the variables in some order. That order is A1, A2 and so on AN. Okay, what is his suggestion is, okay, see if you take I equals to 1, comma j equals to 1. Okay, I equals to 1, j equals to 1. So I equals to 1, then j equals to 1 he is asking, but here it is I equals to 1, j equals to 2 only. Okay, j equals to 2 only. So there is no production matches for this. Okay, no production matches for this. Then I equals to 2, j equals to 1. I equals to 2, j equals to 1. So this is matches. I equals to 2, j equals to 1. So what is that production is? A2 tends to A1 C slash D. Okay, now you can substitute A1 part. What is A1 part it is? Now what is A1 part? So now A1 is, you can substitute A1 in A2 production, that is A2 tends to A2 A C slash, then what is A1 again? B. Now if you substitute B here, it is, now it is B C, then slash D. So this is what, right? Now you observe this. This is the, now it is in the form of direct left recursion. It is direct left recursion. Okay, direct left recursion. You see this, A2 is appeared as the leftmost variable in the RHS part. Now you apply this formula. We have ready-made formula. A tends to A alpha slash beta can be converted into A tends to beta, A dash slash beta, A dash tends to alpha, A dash slash alpha. Okay, so now identify what is this one. So now it is the A and it is the alpha, it is the beta 1 and it is the beta 2. Okay, so how we can write it as? Now it is, so you can write it into the A2 tends to beta. See, actually there is beta 1, beta 2. So take first beta 1. So beta 1 is BC, then A2 dash, introduce new non-terminal. Okay, then A2 dash slash, then beta 2. What is beta 2? Then beta 2 part is D. Now it is D A2 dash, then beta 1. What is beta 1? BC, then beta 2 is what? D. So BC slash D. Then next, what is next one? A dash. Now what is A dash? It is A2 dash, A2 dash, then alpha. What is alpha part here? AC only. Okay, AC. If it is alpha 1, alpha 2, that also you need to consider. Okay, then AC, then A dash. What is A dash? It is A2 dash slash alpha. What is alpha? AC. Alpha is AC. Now this is the direct left recursion is converted into the, this direct left recursion is converted into the a grammar without left recursion. Okay, finally you can write the grammar. How we can write the grammar is, so this is the our initial grammar. This is our initial grammar. It is converted into, so first production is as it is. What is that? S tends to capital A small a slash B. Okay, now this entire part is converted into, this entire part is converted into this one. Okay, now you rename this one. Initially we written as S as S1. Okay, then A as S2, I mean A as A2. Okay, now rename this one. What is A2? It is A. Now it is A tends to B C. A2 dash means it is, you take it as A dash only. Okay, so A dash slash D, then A2 means, A2 dash means it is A dash, then slash BC slash D slash D. Then similarly write down this. What is A2 dash? This is A dash tends to A C. A2 dash means it is A dash slash then A C. Okay, so this is the indirect left recursion grammar. This is the final grammar after removing indirect left recursion. Okay, see, you can cross check it is also. Once you are solving the problem, you can cross check all the problems in formal language and automata theory, because you find out. So this is the grammar, generate the string. What is the first string it generates? B. Okay, same thing. Now S is also generate B. Okay, there is S. Then next, see, S tends to capital A. If I replace A with D, it generates DA. I mean, let me write. So it generates what? DA. So DA should generate here also. Then only it is equivalent grammar. Then only it is equivalent to this grammar. Okay. So how it generates DA? S tends to AA. Okay. Then A can replace with what? A can replace with D. Now it is also generates DA. Correct. Okay, both are generating same thing. That's why both are equivalent. Okay, then we can try with another one also. What's wrong in that? Okay, then let's say S tends to A. Okay, if I replace A with SC, now S can replace with P. Okay, see, let me write down. So S tends to A. Now A can replace with SCA, then S can replace with B. S can replace with B. So BCA it generates. Okay, you cross check whether it generates BCA or not also. Okay, BCA or not also. Okay, you can cross check. So how we can cross check is, so now it is S tends to A. Okay, then A is replaced with what? BC. A is replaced with BC. So BC. A. So it is also generated. So this is how you can cross check your problems. Okay. So this is all about how to eliminate direct left recursion, how to eliminate indirect left recursion. So according to the Moore's, we are converting indirect left recursion into the direct left recursion. Then we are applying this formula.